my screen and you can hear me now, and I'll whiz through. So what we're going to look at today is the engines of the future in terms of technology. Now, when I'm thinking about this from a Microsoft point of view, there's a couple of things to think about. You've heard from some great presenters today about the things they are doing. When you step back and think about actually jumping that curve and innovating, I know Richard from Wise Tech mentioned it in his talk a little bit earlier as well. You've got to think a bit beyond the curve. So lots of the questions we're getting really into the nitty-gritty of what coding do I need to know, what kind of what's my role as a CIO, what kind of things you do, and they're really important questions. But also you got to think about, what the future is. Now, when you're trying to jump the curve, okay, and you really want to innovate, it's really important to start to think about things outside the box, as we call it, okay, or sometimes people call it outside the square. That's harder to do than it seems, right? And it's really important, as you all in Port Macquarie, I used to live in Port Macquarie myself, and you're doing some amazing things up there. There's some amazing tech happening. But it's really important to think, beyond what's happening currently and what's happening next, and that's across everything, whether it's your mobile phones, whether it's services like Netflix and Uber. They've all thought about things which are coming next. So what is next? They're on mobile technology, for example. Now, this example here is what ice farming. 70, 80 years ago, people used to farm ice. Would you believe it? This is a picture from Canada where they had really large ice farms, but they could only do that in the winter. Okay, so they'd harvest it off lakes in the winter time, and then they decided to actually really try to push the boundaries a little bit by actually creating warehouses where they could farm ice, and then they could get those chilled, and they could give you ice all through the kind of seasons. They also then actually try to jump the curve by actually trying to transport that ice really, really quickly using horses. So they were trying to innovate, but they weren't innovating enough. And where you think about where ice is now, the curve was jumped in that area when we had home refrigeration. Okay, so that's a major jump in the curve. They weren't jumping the curve when they were just getting things done quicker or warehousing things. That's just innovating at the time. It's not really jumping to the next thing. It's not the people in Netflix where they were sitting there thinking, you know what, movies and cinemas are dead. Let's invent some way where we can stream videos directly to users. Or people in the music industry saying CDs and vinyls are dead. Let's try to stream it all via Spotify. They were big jumps. They might not seem like it now, but they were massive. So next time you get ice out of your refrigerator, remember that was a big jump in technology. Now, what we're going to talk to today are the three things that we see, the three levers for you to be thinking about for the future. This is where your jobs are going to end up. Now, that might be in different areas. It might be that you're working for other companies. It might be either you're a vet, for example. But all of these things connect together, all right? Cloud. So everybody's moving on their on-prem infrastructure, all the hardware, all the things, server rooms you might see in school and in universities, all of those things are moving into the cloud, right? Which is essentially data centers that are run by corporations like Microsoft and Amazon and Google, for example. So people are moving off-prem into the cloud, really good for sustainability, but it means you can really scale out things like big data and artificial intelligence. So that's really, really important. That's one big driver that I'm seeing at the minute. Secondly is security and privacy. Looking at that is really, really important. We've seen lots of jobs appearing in lots of these areas, data science, for example, from the data and AI area, security analysts from the security and privacy side, cyber is really, really big with governments at the minute, and keeping things secure and also private, really, really important. And then also I put this one in, it's a bit of fun, but it's actually happening now, quantum computing, okay? And when you're looking at quantum computing, well, what's that going to do to industry and the world? So it's all very well thinking about those big things, and yeah, great, Dan, fantastic, but what's actually happening now? So, Microsoft are doing a lot of stuff in Australia with some of our technologies, and this is happening right now, okay? So one of these examples here is where we put facial recognition technology into drones underwater, okay, where we can capture video of fish and actually identify fish and stock inside the harbour in Darwin. You can't jump into the water and count the fish because there's lots of crocodiles in the water in Darwin. So we are using artificial intelligence and facial recognition to do that. Similarly, in Kakadu, we're using AI and drones to actually count birds, identify bird species around the Kakadu region in partnership with Indigenous rangers to really try to look at rehabilitating some wetlands there that have been affected by certain weeds that have actually started to kill off certain bird and avian livestock. So really important to think about usage of these technologies, and they're happening now in Australia. Another example, we've got some AI technology that we're using at the minute to actually monitor turtle nesting across Cape York in Australia. So we can monitor for, there's some animals up there that are kind of feasting on baby turtles, and we're trying to really understand where that's happening, how that's happening, and actually trying to prevent things in that area as well, because lots of the feral animals up there are kind of really destroying the turtle population, for example. Another example of using AI and cloud and cognitive capability is around policing. Okay, so in WA and New South Wales, we've got some really big projects we are doing to use big data to actually correlate information on crimes to actually solve crimes quicker. Now, that might seem quite straightforward, but you'd be surprised, you know, if you think you're a police person on the beat, you find somebody that's done something, you might take their mobile phone off them, you then have got to check their messages, you then might want to correlate any WhatsApp messages they've got, SMS messages, Facebook messages, you might want to correlate certain people and connections, you might be correlating Instagram, TikTok even, and really trying to connect, because people make digital footprints, but there's so many places that people are now connecting and communicating, that you've got to correlate those together, and you can only do that with technology, otherwise it would take a long time. We're also doing stuff with the NRL, where we put in content and digitizing content. We're doing lots of the American football in the US and baseball and NBA, where we bring in fans experiences using the clouds to make people make performances on the field better using data and AI to support, you know, sports analysis, but also to bring fans in using VR and mixed reality and the like. We're also doing things with pathology and doing AI to help really accelerate things like testing of bloods for things like COVID and the like. So there's a lot going on in this area. So when you're thinking about technology, it's about the application of the technology that's important. It's not the technology itself. Okay, it's about understanding, hey, you know, you might not know how to do AI or coding in Python in a major level, but if you know that the capability is there to do facial recognition, for example, then it's about applying that to those particular cases, for example, the police, or for example, to the fisheries or the turtle products that we got going on, projects, sorry. So really important to think about applications, and that's real stuff that's happening now. This isn't you know, futuristic, that's happening right now. So a lot of this is about the cloud. So what do I mean by the cloud? This is an example of one of Microsoft's data centers, a very small part of one. They big as multiple sizes of soccer fields, and we've got multiple regions of data centers around the world, right? Now, what that means is that people are able to spin up more compute and more, you know, grunt basically to run better applications. Now, an example of that, take for example xCloud. Now that xCloud and Xbox, you can think about us jumping the curve here. So this is a real life example of this, and hopefully this resonates with you. When I was talking about the refrigeration thing, at the minute there's this thing called the console wars, right? PlayStation, Xbox, and you release more hardware every year, okay, and better hardware so that you can actually do better graphics and things like that. So you release better better and better consoles each year to 2 years. And there's this thing called console wars that people always argue when everybody releases one, what's the best frame rate, what's the best this. Now, if you were running Xbox in a data center, then you'd never need a console again, because if you wanted the best GPU, you can spin up, a massive GPU. You can connect in 5 Xboxes together, 100 Xboxes together, a million Xboxes together if you wanted to. It would cost a lot, but you can actually scale up your processing that you need. So you can utilize multiple fast processors joined together, the best GPUs in the world, and that's on demand. Okay, so this is where Microsoft are jumping the curb, for example, on Sony a little bit, because we're moving all of our Xbox stuff from the console into the cloud, so you can game on the cloud using your internet. Okay, so think about that for a second. That's Microsoft saying, well, look, we're still going to keep making consoles, but you can get the most powerful console ever on demand anytime. You don't have to wait to Christmas. You can be streaming those games to your television, to your mobile phone, to your iPad immediately. I've been testing this for the last year, and it's fantastic. My kids game a lot, and I game a lot, and the latency is fantastic with the xCloud. So that's released into Australia. It's in preview. It's you might have already got it if you're a member of Game Pass, but that's an interesting skip of the cloud. But what that means is another thing that we've done around gaming using cloud is Flight Simulator. Now, Flight Simulator was one of the first games that Microsoft ever created, and it was rave reviews, and then we stopped it many years ago, and then we brought it back out about 18 months ago during COVID. But we used the cloud to render photorealistic graphics and weather patterns to the second into the game. So there was a big storm in the New South Wales last night. It might have been Port Macquarie there, hit me down in Sydney. You could fly a plane into that storm, see the clouds, see how that's actually working. So all of the meteorological data is in there, for example. So you can only do that if you were processing in the cloud. So it's about thinking, well, okay, if I'm a games developer, how can I utilize all of that capability in there? So the next thing is mixed reality, right? So let me just make sure my audio is going to come through here and play a little video. Now, we've got a tool called Hololens. Now, this allows you to then take cloud computing and physical computing to the next level. All right, we're using this quite a lot in the military and in medical applications, and also in some schools are using this quite a bit around e-learning and the like. But I'm just going to show you this video. Hopefully the sound comes through, and you'll see what I mean by the merging of hardware and software. Oh, let me play it properly. So if you've got a Windows device at home, okay, you can utilize, let me jump past that for a second. You can utilize the power of augmented reality and mixed reality inside your Windows device already. And somebody was asking in the chat earlier on today about Maya and things like that. So the idea being for developing environments and immersive things for things like HoloLens, the idea would be, start with Windows 10. If you've got a Windows 10 or 11 laptop there in front of you today, then go into 3D Paint. It's already baked into your device. Log into it, create some 3D models, and then you can export them, you can print them, and you can even import Minecraft models into there. And then you can actually convert those into all kinds of different formats that you can also import into Unity and Maya and other tools. And then you can actually use Unity, for example, to create those mixed reality games and environments inside HoloLens. So there's a very much an ecosystem taking you through there, but it might look fancy, but that Windows HoloLens is just a Windows holographic device, a PC, untethered, no wires on it, which is running a holographic version of Windows, which means you can see applications in your field of view. So you can pick things up, you can move things around, you can prototype, and you can even call people in. So you can call in, for example, so the army are using that to bring cloud-based data to their visuals, so they can see mapping data, they can see things such as enemies, they can identify planes or whatever it might be, or enemy vehicles or friendly vehicles. So there's a whole heap of things that you can utilize for that, from medical, like I said, to military. So 3D mixed reality, really, really important. Have a play. All the stuff's freely available online. You can Google Microsoft Holographic Academy. There's a whole heap of stuff there. All your resources, all the learning that you need. It takes you through Unity and setting that up. So the final concept today, we've talked about big data and cloud. We talked a bit about mixed reality and HoloLens. The other thing that I'm going to talk to you about is quantum computing. So it's worth you thinking about the future further than, in the next year or two. Now, we're developing quantum computing already, and what that means, you might have done classical computer science, which I did, which everybody does. We know binary, yeah? Binary switch, the light bulb's on, the light bulb's off, ones and zeros, quite easy. But then that means you are limited to what you can do. You just got to do more ones and zeros as you can. Therefore, the transistors and the circuit boards that we've got do more and more and more, and they become smaller and smaller, and they do more and more binary calculations. And that's what speeds things up, okay, and allows us to store more, because it's storing more ones and zeros. But quantum also means that you can be in a particular state at the same time, like multiple states. So you can see here that these are not just on and off, they kind of both states at the same time. And what we call that is a quantum bit, a qubit. So quantum can be on and off simultaneously. So sounds a bit weird and sounds kind of far-fetched, right? If you want to learn more about quantum, look at some of the stuff around Schrodinger, famous physicist. He did a thought experiment called Schrodinger's cat. Essentially, what the physicists used to do is create these, when they would work things out and kind of understand the way the universe was working, they'd pose, some brilliant thinkers pose thought problems, like Einstein and things would pose problems to kind of illustrate, what that means. If a state can be in two things on and off at the same time, how can we explain that? So what he did was explain it with a cat, and I'm going to explain this very badly, so please check online and see if you can see a better explanation. But essentially, you put a cat in a box, it's alive, you put it in the box, and you put a vial of poison in the box, which the cat could knock over. You then close the lid, and if the poison gets knocked over, the cat will breathe in some poisonous gas and then die. So technically what Schrodinger said was that when you close the lid on the box, the cat is in two states. It's alive and dead at the same time. And only when you open the box do you know if the cat's alive or dead. Now that sounds really freaky, but they happens at such a small level, a quantum level, in an atomic level, that it's hard to really extrapolate into real life. You're probably looking at me going, how can a cat be alive and dead at the same time? But that's the principle of quantum science, okay, and quantum physics. So it's an important one to think about. And how does that affect us in terms of computer science? So for example, if I wanted to turn that light bulb on using traditional computing, I'd follow all the paths. So I'd follow one path around, no, dead end, another path, dead end, another path, dead end. You do with your eyes now when you see this on the screen. Follow some of those paths through. See how many paths there are. You have to test them all. You can't just test one. If you're lucky on your first time, great. But test them all. You keep going and keep going and keep going. Now that takes time. And that's what a binary computer would do. It would test something, test something, test something, test something. But what quantum does is it means you can test those things at exactly the same time simultaneously, and it'll give you this graphic. So if you test everything at the same time, then you get the answer much quicker. So that's what they mean when they're talking about when quantum is built, problems can be solved faster. You know, encryption can be cracked sooner. So it also brings some pitfalls with it as well. So it's really important for us to think about that. We've invented a language called Q#, so you can start working with quantum computing now if you wanted to, but it is going to have a profound effect on everything from security to banking to health. You know, the speed at which we're going to be able to do calculations is going to be phenomenal. So we teamed up with several areas in Australia. Again, we've got a place called Station Q in the University of Sydney, which are dealing with quantum at the minute and trying to break through with that. There's several companies, Google and Amazon, are also looking at getting a productionized quantum computer in the next couple of months. So this is moving on really, really quickly. So that's why we also build an ecosystem around that of programming languages, and you know, you're going to be able to spin up your own quantum machine in our Azure cloud in the next couple of months, fingers crossed. So, you know, really, really exciting project. But what does that mean then? So let's just try to bring that to life a little bit. Let me make sure my audio is sharing for you. Yes, it is. And let's watch this video.
Talk about quantum computing, it's a completely different game.
Quantum computing will enable us to solve problems that currently take longer than the lifetime of the universe in seconds, hours, or days.
We completely reconceive the space in which we do computation.
Quantum computing is like going from crawling to going to a different planet. It's different.
It's only natural that we would want to use the world's most powerful device to combat the world's most challenging problems.
We could attack global warming.
Security.
What are the boundaries of machine learning?
Fighting diseases. The possibilities of quantum computers are endless. Microsoft has the best and the brightest working on this problem.
It's really happening. Progress is very fast, and we're building a quantum computer.
What the world wants to know is what happens when we turn the machine on.
What problems will be solvable with a computer that computes in a billion parallel universes at the same time?
So that's pretty clear, right? It's sort of as clear as quantum can get, but you can see that this can have a profound effect on everybody and the world. So we've talked about a lot. We've talked about artificial intelligence, big data, some security, some cloud stuff, about innovating and thinking outside the box. We've looked at quantum computing. But let's take it back to like the current day and the questions you're all asking, you know, well, what can I do about this, Dan? You know, I want to get involved. I want to be on this bandwagon. I want to be like ahead of the curve myself. How can I do this? So it's really important to think about what you want to do, right? And where you want to go with this. Now, it's not necessarily just about, say, working for Microsoft or whatever. So using those technologies, I suppose, from the Microsoft point of view, we create a platform, take Xbox, for example, and then people build upon it. So that's why I like working for Microsoft, because we create a platform and we need people to make millions of dollars on our platform, right? Like the games on Xbox, right? The people that make the games on the Xbox make the money. We create the Windows platform and the Azure environment in the cloud, and we want people to be doing the cool stuff on there, like the drones for the finding the birds and the turtles and underwater drone stuff, and using quantum to actually start to kind of understand various viruses and finding cures for things like cancer and the like. So it's really important to think about where you're going to start. Now, you might be thinking, oh, this is so complicated, Dan. Well, what do you expect me to do? So there's lots of learnings that you can do, okay? Now, this is a slide that I share with like enterprise customers, not just necessarily with students, but with people who are working with you with enterprises. So I shared this with the Royal College of Surgeons yesterday. So we've got a website called Microsoft Learn. You can go to that now, and all of our courses are on there for free. You can go on and get all your course information. You can do the exam, you can sit an exam, and you can even identify your skills. If you go to aka.ms/certification, it'll ask you some questions and then identify pathways for you. You know, some of you might be want to go into web development, some people in data science, some people in security, some people in other areas. So you can go through that. You know, Microsoft's always been really big on making sure that we certify and support the workforce and upskill the workforce in Australia, because ultimately we need you to be working for us or for companies who work with Microsoft technology, like you might hear today. You know, say for example the Adobe software, you know, that's running in our Azure cloud. A lot of their stuff that they are running through, lots of the stuff the Wise Tech are doing are probably running in some Microsoft services as well. So, you know, there's lots of partners in Australia that are kind of helping and driving different industries, and they're the ones to also look out for, because they're using cool tech which Microsoft have invented to kind of drive that forward. So I'd start with microsoft.com/learn, or just type in MS Learning into your favorite search engine, and then really start that pathway, because there's a lot of things that you can actually do, and the future is yours to make, right? It is you can do whatever you want, and this technology, school, university, they're good, but they're not going to help you get as far forward and as quickly with some of these technologies as learning yourself. So really sit down. If you really want to learn Python or you want to learn C#, don't wait for your school, don't wait for a college degree, don't wait for TAFE, just have a crack yourself, you know, give it a go. You know, I've employed people in Microsoft because they've been really interested in the technology and they understand it, and they've been hacking away at Raspberry Pis and Arduino devices and utilizing Azure for Internet of Things and things like that. So, you know, go and give it a crack. Okay, so that's my tip, I suppose. The future is yours. We've covered a lot today. I'm gonna stop talking for a while and pass back to Lily, but I'm happy to speak to you and answer any questions that you might have.
Great. So we'll start off with I guess a pretty simple question. How did you get your job at Microsoft?
That's an interesting question. So my job at Microsoft, I was a teacher, actually, randomly. I finished school, did a computing course, and then decided to do teaching and taught computer science, and then taught in university as well. And then I kind of thought, well, what can I do now? You know, because the teaching element was really fun and I was really enjoying it, but I wanted to get my hands dirty again. So I utilized my background in computer science to kind of then get a job in Microsoft to work with them to kind of support the education industry in Australia. So I really kind of started to push the boundaries in that area with my own knowledge as well, and learn on the job as I went, I suppose. So it's a traditional way, but like Damien mentioned as well, you know, don't worry about what degree you do or whatever course you do. You know, you end up in different areas. Your road meanders along, and mine has as well. And I'm sure everybody's on the calls have today as well. But yeah, I went through traditional pathway.
Nice. And touching back on your time as a teacher, we have a careers advisor here from Tamworth. And they often talk to students who are keen about ICT careers, but being in a regional area, they find that the opportunities to connect in person with companies like Microsoft and other large businesses in, I guess, IT and technology are very limited. And so they were wondering if you have any advice or feedback on how they can even out that in-person opportunity between the metro and non-metro students.
Yeah, that's a good point. And like I would say that you know, I've been to Port Macquarie multiple times. Microsoft have got offices in every like region in Australia, every capital city, and then you know people live in everywhere. So you know, lean on the companies. You know, all the companies you've spoken to get today. They don't necessarily all live in Sydney and in New South Wales or Adelaide or whatever. They live in regions as well. So I get in touch with them and ask to get people in to speak to students, because I do this often, and lots of my colleagues do as well. So the big day in, as you know, we've gone around thousands of areas over the last couple of years, not hundreds of areas anyway. But and they've been lots of that's been in regional areas like Wagga and things like that. So you know, reach out to the companies, because you'll be surprised down the road you might have somebody live in who can come into your school from those companies. So please reach out to them. But it is an important one, because it's important from an Indigenous point of view. For example, it's very important that people also stay in their local and regional areas. They don't just feel as if they've always got to come to Sydney or go to Brisbane, because it moves people out of regional areas, which are really important in Australia. So, you know, it's important to start to create startups, speak to startups. There's lots of startup and meetups in your community. I'd start there as well. So it's not just about the global tech companies, it's about your local companies, your local computer shops, your local IT companies and things like that. So, you know, make sure you connect with them, you know, go to the meetups, create your own meetup, get your own tech meetup going. Start one at your school and get industry to come to you.
That's great. Thank you so much. And also along the lines of teaching, as a high school student, where can they start learning about AI or machine learning? Because their school doesn't offer those kind of subjects.
Yeah, that's right. And no schools or universities really do. So the key thing is that you go online and have a crack yourself, because that's what I said towards the end of the presentation. Go to Microsoft Learn. All of our content's there. We have face-to-face things you can sign up to. We have online stuff in the minute in COVID that you can sign up to. You can register. We have lots of events on, lots of things. You know, Imagine Cup Junior is a competition that we run. It's a worldwide one, and lots of Australian schools won it last year. But you can do that. You can connect in with ACS and people as well to give you some advice. But all of our content's online, and if you're interested in that, then pick it up and learn it, and take hold of that learning yourself and get the badges and the certifications. You know, you can get the certifications. You do an exam. It's $99 for the exam if you wanted to do an official exam at the end of doing the course. Otherwise, you can just do the course and, you know, create a LinkedIn profile, put those things on your resume, and make sure that you're showing people that you're kicking some goals.
Yeah, that's great. And I think for a final question today, it seems like a very popular one, goes back to your time as a gamer. What do you think about the new Minecraft update?
Everybody asks me about Minecraft. I used to run Minecraft in Australia. Yeah, you know, we've got multiple flavors of Minecraft, and the new updates, you know, there's multiple new updates, so it depends which one you're talking about. But you know, we're trying to bring as many new characters, applications into Minecraft as we can, but we're doing it in the spirit of the game itself. So we've got to be very careful, because the community is quite picky. So you've got to be really careful when you're releasing updates. So Some of the ones we've just released recently on the education edition are underwater and aquatic stuff, chemistry, connections, and heaps of coding stuff. You know, in the version online, we've got different animals that we've just released in there, different biomes. So, you know, I just hope it keeps going, to be honest with you, and I hope you love it. And if you want the feedback, go online and talk to our teams. They're all on Twitter, they're all on Instagram. The engineers are there. You know, tell them what you want, and I'm sure we can add it.
Great, thank you so much. I'm sure all of our gamers out there will enjoy that, and all non-gamers, because I'm sure Minecraft is a very diverse game. Yeah. All right, thank you so much, Dan, for that amazing presentation.
Cool. No problem.
So I hope